Here we are in the third video looking at how to take the derivative of some of these problems. Problem number 11, once again, we have an outside and an inside function. The outside function is something being taken to the negative third power, so we'd use the power rule. And my inside function here is that x to the fourth plus 2. So our derivative would be the derivative of the outside function, which would be that, using the power rule. Then the derivative of the inside function, the derivative of x to the fourth plus 2 will just be 4x cubed. We can clean this up. Both this and this are in the numerator with this term taken to the negative 4 power being in the denominator, this expression. So multiplying a negative 3 times 4 will have a negative 12x cubed in our numerator, and x to the fourth plus 2 to the fourth in our denominator. That would be the simplified form there. Once again, in problem 12, it looks like we're rocking the chain rule again. So we have our outside function, which is the natural log function, and we have our inside function, which is the x squared e to the x, which we will have to use the product rule on. So for this one, we have not only the chain rule, but for the inside function, we also have the product because we have two things being multiplied there. So we're going to start with the chain rule, where we have 1 over x squared e to the x. Awesome. Now we have to take that times, that's the outside function. Now the inside function's derivative will be the product rule. So it'll be the first times the derivative of the second. The derivative of e to the x is just e to the x, plus the second, e to the x, times the derivative of the first, which will just be 2x. Cleaning this up, we'd probably write this as one fraction. And that'll be x squared e to the x, and plus 2e to the x over x squared e to the x. Now I notice both of my terms in my numerator have an e to the x in them, and there's an e to the x in the denominator. So we can simplify this fraction. Both of these terms also have an x in them. So we're going to be able to simplify the x parts also. So I'm going to, from these two terms, I'm going to factor out that e to the x and an x to the first power. If I do that from my first term, it'll only have one x left. And back here, I'll just have a plus 2 because my e to the x and x have been factored out front. And down here, we have x squared e to the x. Well, now these e to the x's will cancel in each place. And this one x will cancel with one of these x's. So what we'll be left with, essentially, is x plus 2 over x. And you could split that fraction up if you wanted and simplify it further, but this works fine. In problem 13, it looks like we have a massive chain rule incident. We have the outside function, which involves the power rule. We have the next function, oops, sorry about that, which is the natural log. And then from there, we even have a further inside function, which is the x squared plus 3. So we've got to use the chain rule multiple times. First, we'll take the derivative of the outside function, which is just being taken to the 3/2 power. So that'll mean 3/2 comes down in front, and then we just leave the rest of this the same, natural log of x squared plus 3. But now, if we subtract 1 from 3/2, that's to the 1/2 power. Now we'll have to multiply that times the natural log derivative. So now if we do the blue derivative, that'll be 1 over the x squared plus 3. That's our derivative of natural log. Now we'll take the derivative of the green part, and the derivative of x squared plus 3 is 2x. Lovely. All right, looking at this, there appears to be some things we can cancel. I can cancel, I have a 2 and let's look at what's in the numerator and what's in the denominator. Everything here in dark blue is in the numerator except the 2. The 2 is in the denominator. In purple, this x squared plus 3 is in the denominator. And in green, the 2x is in the numerator. But since this 2x is in the numerator and this 2 is in the denominator, they can cancel. And let's see if we can write our final product here. We'd have 3 times the natural log to the 1/2 power. Oops. Let's go 3 and an x because there's an x here too. So 3x times the natural log of x squared plus 3. And this whole thing is to the 1/2 power. So square rooted. And that's all that's in our numerator. What's left in our denominator is x squared plus 3. And of course, we can't cancel this x squared or that 3 because they are not being multiplied. So our denominator can't cancel with anything in our numerator. And that is our final answer. All right, let's go ahead and look at problem 14. Once again, problem 14 involves the chain rule. Our outside function is a base taken to a power, and the inside function is that exponent. So looking at 14, taking the derivative of 8 to some power, it's going to be 8 to that power times the natural log of 8. Now we want to take the derivative of this inside function, and the derivative of a 1 minus 2x squared, I believe, would be a negative 4x. Now, I can't multiply this 4x times the natural log of, well, we can't combine them and make say it's 32 in any way here. We also can't do this with this green 8 because 8 is being taken to that power, so I can't multiply the 4x by it. So that is, in a sense, our lovely derivative for problem 14. In our next video, we will go through the rest of the worksheet. Thanks for watching.